Hi students, today I am going to explain CBSE sample paper class 12. Okay, now first let us see the CBSE sample paper physics class 12 consists of three sections, section A, section B and section C. Section A consists of 25 questions, you should attempt 20. Section B consists of 24 questions, you should attempt 20. And section C 6 questions, you should attempt 5 questions. That means totally there are 45 questions you should attempt. For the 45 questions you will get the 35 marks. That means for one question equal to how many marks it is there. The one question marks not exactly equal to 1 mark. One question is the 35 by 45. That means 0.77 marks are there. Each question carries 0.77 marks. Okay, let us go for the sample paper and its solution. Okay, right, let us start. Let us see the first question. Which of the following is not the property of equipotential surfaces? Equipotential surfaces do not cross with each other. It is true. It is a property. The rate of change of potential. Equipotential surface means oh, change in potential should be 0. Okay, and uniform electric field. In the uniform electric field, for example, we are taking the uniform electric field like this. In the uniform electric field, equipotential surfaces are like plane. They are not like a sphere. Okay, that means here in the third one they gave that equipotential surfaces in uniform electric field they are the concentric spheres, but they are not concentric spheres, they are the plane. Okay, they are can imaginary spheres. Yes, the third option is the right option. Let's go for the next question. That is, there are 2 point charges plus 8q and minus 2q are located at x is equal to 0 and x is equal to L. Let us see here. This is x axis. On the x axis at x equal to 0, there is one charge is there, that is plus 8q, and at x is equal to minus 2q there is another charge is there, right, at x equal to L, that is minus 2q. Okay, and these two charges are separated by a distance L because this location is L. Then question is that what is the point on the x-axis at which electric field is 0? At what point the electric field is 0? For example, if you take one point at this location, if electric field is 0, whether it is 0 or not we will see. Due to plus 8q the electric field is right side, that is E1. Due to minus 2q also electric field right side, that is E2. That means at point A E1 and E2 are along same direction, that's why it never be 0. Then we will take another point B. What about this point? At this point due to plus 8q the electric field is right side because electric field is away from positive charge, and due to minus 2q the electric field is negative, that is towards minus 2q. That means at point B, right? At point B, the electric field may be 0 because at point B, electric fields are in opposite direction. Then that point distance required, point position is required. Then for the purpose, right? At point B, E1 is equal to E2 we can write. If E1 is equal to E2, then electric fields will be cancelled and net electric field we will get as 0. For example, that point B distance is R from the center. Here we have tried the E1 formula. E1 formula is what electric field due to point charge formula, 1 by 4 pi epsilon naught into charge by charge distance we have to take. Charge is 8q. 8q distance from point B is from the figure R plus L whole square we have to write. and that is equal to E2 due to electric field due to minus 2q charge. That is 1 by 4 pi epsilon naught into minus 2q. We should not take the minus sign. 2q by that minus 2q distance we have to take, that is from point B r square. Now something will be cancelled and qq also will cancel, and if you do the cross multiplication we will get a 8 r square is equal to r plus l whole square we will get. Is it right? On the right side there is a 2 is also there, right? If you cancel this 2 2 4 ja, on the left side it will remains as 4r square, right? It will remains as 4r square equal to r plus l whole square. If you will square root on both sides, 2r is equal to r plus l. Finally we are getting the r is equal to l. R is equal to l, right? Now I want the position at which net electric field is 0, right? The position at B, right, where E is 0, where net electric field is 0, right? That position how you will get from the figure, this point B distance from origin, if you will want to get, that is from the figure R plus L, that is R plus L means L plus L, we will get answer as 2L, that is the 2L is the right answer. Okay, right. Now let us go for the third question. What is our third question? The third question is that the electric dipole moment P is placed parallel to the uniform electric field. This is a dipole, right? Dipole means equal and opposite charges separated by certain distance. It is a dipole. The dipole is kept in the uniform electric field. Initially, it is kept parallel to the electric field. That means the angle between the P and E is 0, initial angle. And now it is rotated in such a way that the P makes an angle 90 degree with the electric field. Finally, the dipole is rotated, that is in such a way that final angle is 90 degree. Then our question is that what is the work done? Yes, work done formula is PE of cos theta naught minus cos theta. This is the formula. Okay, and W is equal to PE of cos theta naught is what? Cos theta naught is cos 0 and 90. Next one is the cos 90. And next PE of cos 0 value is 1 minus cos 90 value is 0. And finally work we are getting as PE. That means the second option is the right option. Okay, right. And the next, let us go for the fourth question. There are three capacitors, right? They are connected in the series. In the series, what is the formula for the effective capacitance? Right? In series, we want to find out the effective capacitance. That is, its formula is 1 by C1 plus 1 by C2 plus 1 by C3. But in the parallel, in parallel, there is another formula is there. In parallel, the total capacitance we should add just C1 plus C2 plus C3. But in this question they gave only series, right? There are three capacitors are connected in series. Then effective capacitance we will get is 1 by Cs is equal to 1 by 2 plus 1 by 3 plus 1 by 6. We have to do the LCM and we have to simplify it. If you do the LCM we will get the 6, and in the numerator 2 3 ja 3 2 ja 6 1 ja. Finally 6 by 6 we are getting, then that is a 1 we are getting. That means Cs is equal we are getting as 1 microfarad, right? This is the answer. That means the second option is the right option. Let us go for the fifth question. The fifth question is that 2 point charges, right, are placed in dielectric medium, right, whose constant is phi. In dielectric medium we know force in medium is equal to is equal to 1 by k times of 1 by k times of force in free space. This formula very well you know, right now students? Force in free space. Now the force in medium in the question they gave F, and dielectric constant they gave phi. Force in free space they are asking in this question. Then it was very easy to find out the force in free space from the given data. Just we have to take the phi to left side, then we will get the force in free space as phi f, right? Okay, completed. That means the first option is the right option. Let's go for the sixth problem. Okay, sixth one is the which statement is true for the Gauss law. Okay, and it was very simple. You remember that first one is what the charge Gauss theorem is applied for the non-uniform electric field. Which statement is true for Gauss law? All the charges, whether inside or outside Gaussian surfaces, contribute the electric flux. According to the Gauss law, only inside is considered, not outside. That's why this is wrong, right? And electric flux depends upon the geometry of the Gaussian surface. In electric flux depends upon the geometry. That is not depends upon the geometry. It is it is also wrong. Electric flux does not depends upon the geometry. It does not depends upon the geometry. And Gauss theorem is applied for the non-uniform electric field. Gauss theorem is applied for only uniform electric field. This is also not correct. And electric field over the Gaussian surfaces remains constant and continuous, uniform at every point. This is the correct answer. It is true regarding the Gauss law. Let's go for the seventh question. That is, a capacitor of plates is charged by a battery V volts. This is one capacitor whose capacitance is C. It is charged by a battery. The battery potential is V. Okay, we are charging the capacitor by a plug key. Then it charged to a potential V. After charging, we are disconnecting the battery. And what we are doing after charging, for example, on this Q charge is there. After charging, I am disconnecting the battery and I am introducing some dielectric slab at here whose dielectric constant is K. Now, what happens to the potential difference? New potential difference is what? In this case, potential difference, what happens? Actually, the initial charge we can consider as Q is equal to CB and potential we can consider as Q by C. That is, for example, final potential if you want, then we write it the final charge Q dash, and the final capacitance C dash after introducing the dielectric slab. What we are doing it here, capacitor is fully charged by a battery. After that, battery is removed and dielectric is introduced. Then what happens to the potential difference across the capacitor? This is our question. Right? Okay, a capacitor charged by a battery with V volts. After charging, the battery is disconnected. Dielectric slab of dielectric constant K is inserted between the plates. The potential difference across the plates is what? V dash equal to Q by C dash. You know very well that whenever the battery is disconnected, the charge will be remains constant. Amount of charge will be constant. We write Q dash as Q only. And capacitance, what happens? C dash. Okay, when the capacitor dielectric is introduced, the capacitance become K times. Capacitance become K times. We write as Kc. Right? Then here we write as the Kc. Then 1 by K into Q by C we have to write. What is Q by C? Q by C is the old potential. That means now when the dielectric slab is introduced by disconnecting battery, the potential become V by K. This is the seventh question. That means third option is the right option. Let's go for the one more question. Which instrument is the best to measure the EMF of a cell? Right? The potentiometer is the best to measure the EMF. Right? And meter bridge is used to measure the resistance and specific resistance. And potentiometer is used to measure the EMFs, and it is also used to compare the EMFs of two cells, and it's also used to measure the internal resistance of a cell. Voltmeter also measures the EMFs, but right, it will not measure accurately. When you go for the accuracy, then the best is the potentiometer. Okay, the answer is the first option. Let's go for the next question. That is the ninth question. Electric current. Electric current. Electric current is passed through the circuit containing two wires of same material. Same material if they will give, that means the resistivity of the material is constant. Okay, electric current passes through the circuit containing two wires of same material connected in parallel. Connected in parallel means in parallel potential is constant. Okay, look at here. There are two materials. For example, it has the resistance R1, it has the resistance R2. the two materials are connected in parallel as shown in this figure, right? You see, and the two materials are made with the sorry two resistors are made with the same material, okay, right? And when they connected in the parallel, their potential is also same. Potential is also same. Now they are made with the same material, that's why resistivity is constant. They gave some values, that is the lengths are in the ratio, lengths are in the ratio 3 by 2 and the radii are in the ratio 2 by 3. Then our question is that current passing through the two wires will be in the ratio. We should find out the ratio of current passing. For example, the current through the first wire we can consider as the I1 and current through the second wire we can consider as the I2. We have to find out the current through the two wires. Then how we can find out the current? Then for the purpose, current formula is we know V by R, right? V by R. Here V by R formula we write as rho L by A, right? A goes to numerator, V into A by rho L we have to write. A is the area of cross section of wire, we write as pi R square by rho L we write. Area of cross section of wire is in circle shape, that's why we have to write like this. The current depends upon some factors, V constant, pi constant, rho constant. Here we write as current proportional to R square by L. When you write the ratio form, I1 by I2 is equal to write as R1 by R2 whole square into L2 by L1 we have to write. Okay, now you substitute the values in this, you will get the answer. R1 by R2 whole square means 4 by 9 we will get. L2 by L1 means we will get as 2 by 3. Finally answer is 8 by 27 we will get. Okay students, right, let us go for the 10th question. Okay, what is the 10th question? If you increase the temperature, what happens to the specific resistance of conductor and semiconductor? For the conductors, in case of conductors, okay, when temperature increases and then resistance and resistivity also increases. Resistance and resistivity also increases. Now in case of semiconductors, in case of semiconductors, when temperature increases, if temperature increases, then resistance and resistivity both are decreases, right? That means increasing temperature, if the temperature is increases, then in case of conductor the specific resistance is increases and in case of semiconductor it will be decreases. That means the third option is the right option. Why the alloys are used to make the standard resistors? 11th question, let us move on. Why use alloys for making standard resistors? Standard resistors means its resistance should be constant and its resistivity should be constant. It should not change with the time. For that you have to select with low temperature coefficient of resistivity and high specific resistance we have to select. We have to select a material with low temperature coefficient and high specific resistance. Okay, low temperature means with the temperature variation is negligible. High resistance means it has more specific resistance and more resistance also. Next one is the 12th question. What is our 12th question? A constant voltage is applied between two ends. Okay, read properly what they gave in this question. A constant voltage is applied between the two coils. Okay, constant voltage is applied. Constant voltage is applied between two ends of uniform metallic wires. Heat H is developed in it. If another wire of same material, double the radius and twice the length as compared to the original wire is used, then heat developed across it is what? This is our question. Here you see the constant voltage is applied. Constant voltage is applied that they gave in the question. Okay, firstly one wire is there. There is one wire, first wire. Okay, the first wire, if you see the first wire, you see the first wire. Okay, in case of first wire, what happening? In case of first wire, for example, the length we can take as L and radius we can take as R. and the heat developed across it we can consider as the H1. Okay, there is another wire is there, another wire, that is the second wire. The second wire data they give, it is also made with the same material. Same material means resistivity is constant. Remember, in the question constant voltage they give, same material they give, same material means voltage resistivity should be constant. And we are selecting the second wire with the same material, but the double the radius, twice the length. Length is 2L and radius is 2R. Then across this if you apply the same voltage, how much heat develops? That is our question. Okay, in the first wire the heat developed is H. In the second wire what is the heat developed? That is our question. Then for the purpose, heat developed formula is what? Heat developed also equal to V square by R into T, one formula. I square RT also V is there, but we don't use the I square RT. It's not valid at here because I is not constant at here. Okay, and here V is constant. Then here we write as the heat is inversely proportional to R. Here we write as H1 by H2 is equal to R2 by R1. We have to find out the ratio of resistances. Then the resistance formula is what? Rho L by A. A is the pi R square. Then here we write as R proportional to L by R square. Now we should write the ratio form, that is R1 by R2 is equal to L1 by L2, right? L1 by L2 whole square into, sorry, not square, right? R2 by R1 whole square. L2 by L1 is what? L1 by L2 is what? Whenever L is in numerator, we write 1 by 2. It is R is in denominator, we write 2 by 1. L1 by L2 is what? L1 by L2 is L by 2L. That is L1 is L, L2 is 2L. Then 1 by 2 we write. And R2 by R1, R2 is 2R, R1 is R. 2R by R, that is 2. 2 square means 4. Okay. And if you simplify this, we are getting the 2 by 1. But here the heat ratio they are asking. The heat ratio they are asking. Then what you will get the heat ratio? Right? We know heat ratio, that is H1 by, not heat ratio, the H1, this is equation 1. From equation 1 we write one thing, that is the heat developed across the first wire is H, heat developed across the second wire is H2. R2 by R1 we write as 1 by 2. Here H2 we will get as 2H. That means the right answer is the third option. Okay, like this we have to solve the problems. If you have any doubt, you can write in the chat box. Let us go for the next question. That is question number 13. What they gave in the 13? You see, the potential difference across a conductor is increased to 2V. Temperature is kept constant. What happens to the drift velocity? Okay, this is a wire. This is a wire. Across the wire, what we are keeping the constant? Right? Temperature we are keeping the constant. By keeping the temperature as constant, and if you double the potential difference is doubled from V to 2V. What happens to the drift velocity they are asking? There is a formula for the drift velocity. Okay, one formula is capital E into small e by m into tau. There is one formula, and another formula is I by NAE. Okay, and from this I we write as V by R. That means NAE into R we write. Then or otherwise electric field formula also we can write V by D. Right? V by D we have derived. Then from this we write drift velocity proportional to the potential difference. Drift velocity proportional to potential difference. That means if the potential difference is doubled, automatically drift velocity also doubled to its initial value. Okay, let's go for the 14th question. What they give in the 14th question? The 14th question is that we have to find out the effect resistance between the A and B. Here you should change, these are not appearing. This is 3 ohm and this is 6 ohm and this is 8 ohm and this is 30 ohm. Okay, and this point is A and this point is B. Let us start the solution. That is right, and that is first. You see here I am rearranging this diagram like this. From point A you can start. From point A it is connected to 3 ohm, right? It is connected to 3 ohm. Then next it is connected to 3 ohm, one end is connected to 8 ohm. 3 ohm, one end is connected to 8 ohm. Okay? And you see here 8 ohm, one end is connected to point B. And from the A we started the 3 ohm, 3 ohm to 8 ohm, 8 ohm to B. Next from A we are connecting to 6 ohm also. From A you start like this. It's connected to 6 ohm. Okay. And then after that the 6 ohm second end is connected to second one is connected to 8 ohm. Next from A it is also connected to 30 ohm. You start from A only. It's connected to 30 ohm. 30 ohm. The 30 ohm second end is connected to a point where the 8 and 30 are meeting. Right? 8 ohm second end we are connecting. Here you will connect. This is the equivalent diagram. Equivalent diagram. Then we have to find out the effect resistance between A and B. Then how we can find out? 3 and 6 are in parallel. 3 and 6 are in parallel. Then effect resistance of 3 and 6, what you will get it here. That is 3 into 6 by 3 plus 6. You will get as 18 by 9. 2 ohm we will get. This 2 ohm and this 8 ohm is in series. Then effect resistance in this line will become, right, 3 and 6 combinedly gives 2, that 2 and 8 are in series, then 2 plus 8, that is in series, we have to add 10 ohm we will get in. Now next one is the R2, we will take this one. This R2 is the 30 ohm, and this will become like this, that is just this is the point A and this is point B, and this resistance is the 10 ohm and next one is the 30 ohm. It is a equality diagram, right? 10 30 are in parallel, then effect resistance formula is R1 R2 by R1 plus R2 in the parallel combination. Okay, right, listen once again very carefully, it was very easy to find out. Okay, you see here we have to find out the effect resistance between the A and B. In this case, first 3 and 6 are in parallel, their effect you should find out. Then they combinedly it will be replaced with one resistor whose resistance is 2 ohm. These 2 and 8 are in series. Their effective is 10 ohm. And here 10 ohm is there, here 30 ohm is there. Their effective I want 10 into 30 by 10 plus 30. Then we will get as 300 by 40 we will get 0 0 cancel, 2 2 ja, 2 15 ja, then 7.5 ohm we will get. This is the answer. Next let us go for the one more question. What is the SI unit of magnetic field intensity? We can write from force formula. Force formula is the ILB sin theta. IL sin theta. Okay, B is equal, we write as F by IL. Then F for unit is Newton, I unit is ampere, area unit is meter square. Newton per ampere meter square. That means Newton A inverse meter power minus 2. This is the unit of B. Okay, right. B unit magnetic field intensity. Right, the B unit is what? Okay. Next one is the a coil of moving coil galvanometer is wound over a metal frame. Okay, moving coil galvanometer is wound over a metal. Okay, that is the soft iron. What is the reason? What is the reason? Okay, to provide the electromagnetic damping. Okay, to provide the electromagnetic damping. Next one is the 17th question. What is our 17th question? Okay, look at here, the two wires of same length are shaped into square and square of side A and circle of radius R. If they carry same current, the ratio of the magnetic moments is what? Okay, there are two wires. Okay, the first wire has the two wires have the same length. First, the wire converted into square whose side is a. First, the wire converted into square. This wire made like square, right? Square means all sides are equal. At that moment we write one condition, right? The square four sides length is 4a, it is equal to a. Then from that, because the four sides length is 4a, this L length converted into four sides, that's why 4a is equal to L. Then a is equal to, we will get as L by 4. L is the total length of the wire. Okay, and it carries some current. Now it carries some current. When it carries some current, it has some magnetic moment that we can consider as M1. And next, the another wire, this is the first wire, has a length L, it is converted into square. There is a second wire, it is also have the same length L, it converted into circle, right? The two wires of same length are shaped into square of side A and circle of radius is smaller. Second one is converted into circle. Circle radius is smaller. Right? The circle length is what? Circle length is what? 2 pi r. Is it correct? Circle length is 2 pi r. From this we write as 2 pi r. This L length converted into circle. That means we write as 2 pi r is equal to 2 pi r is equal to L, and r is equal to, we write as L by 2 pi. What is our question? That when the current passes in this circular wire, it also behaves like magnet. Its magnetic moment is M2. They are asking the ratio of magnetic moments. Magnetic moment of magnetic moment formula is what? Current carrying coil or the loop behaves like magnet, and its magnetic moment formula is what? Magnetic moment formula is NIA. NIA. N is the number of turns, I is the current, A is the area of loop. Here the number of turns is 1 and I is the current, A is the pi r square. Area, A is the area. Okay, A is the area. Okay. Now in this question, you see, if you see that one magnetic moment formula is IA, but the A is the area. Okay, remember it. What is A in this? Area of loop. Area of loop is A, right? Now here current is same they gave. That's where in this you see the current is same. When the current is same, magnetic moment proportional to area. If you find out the ratio, we will get like this, right? Magnetic moments ratio I want. What you will get M1 by M2 from this A1 by A2. Area of the first loop, second loop. First loop is in square shape, that's why its area is A square. Second loop is in circle shape, its area is pi r square. Right? A square means what? A square, how we can find out? A square is the, in terms of length, if you will write L by 4 whole square, we write. And pi into r square, if you will write L by 2 pi whole square, we write. And if you simplify this, we will get the answer, that is pi by 4. Okay, that means the third option is the right option. Okay, and let us go for the next one. The horizontal component of earth magnetic field is root 3 times of vertical component. Horizontal component is the BH, it is the root 3 times of the vertical component. Okay, for example, net earth magnetic field at a particular point is B, and that is making some angle with the horizontal. That angle is called as angle of declination, angle of dip. This is called as angle of dip. Okay, now the B is resolved into components. Horizontal component is BH and the vertical component is BB. There is a formula is there. Horizontal component BH is equal to B cos delta and the vertical component BB is equal to B sin delta, we write. And the next, if you find out the ratio BB by BH, we will get as tan delta, where delta is the angle of dip. BB is the B is the net earth magnetic field. BB is the vertical component. BH is the horizontal component of earth magnetic field. Earth magnetic field is B, that is making some angle with the horizontal. That earth magnetic field resolved into two components, horizontal and vertical component. Horizontal component is BH and vertical component is BB. In the question they gave that the horizontal component is root 3 times of vertical component. Then our question angle of dip is what? We have the formula for the angle of dip. Tan delta is equal to BV by BH. Then from that, if you substitute the BH formula, root 3b we will get and BB gets cancelled. We will get the tan delta I is 1 by root 3. What is delta at here? If tan delta is 1 by root 3, then delta we write as 30 degree. 30 degree converted into radians, that is the 5 by 6 radian. That means the first option is the right option. Okay. Now let us go for the next question. The next question is that 19th question. What is the 19th question? You see, the 19th question answer is the angle between the magnetic axis and geographical axis. Angle between the magnetic axis and geographical axis. It is called as magnetic declination. Next 20 question. Question number 20 is that two coils are placed close to each other. The mutual inductance on what factors depends. The mutual inductance formula is nu r into nu naught n1 n2 a l we write. Okay, this is the formula for the mutual inductance. Mutual inductance between depends upon the relative position and orientation of coils. Okay, and the next one is the a square loop of side L. This is a square loop whose side is L. Square loop means all sides are equal. It's a square loop whose side is L and its resistance is R. Total resistance is R and moves with velocity, uniform velocity v in the magnetic field of induction v in time and space, pointing perpendicular and into the plane of the loop exists everyone. The current in the loop is what? They are asking the current in the loop. This loop is moving in the magnetic field. At the moment, what is the current in this loop? Current formula is the, okay, first EMF we can find out. According to the Faraday's law, what is the induced EMF formula? Induced EMF formula is minus rate of change of negative flux, negative rate of change of magnetic flux, negative rate of change of magnetic flux. But here the flux is constant. Why flux is constant? Why flux is constant? Flux depends upon the field and area. Flux is equal to BA cos theta. Okay, but here theta is 0, B and area vector are in same direction. Flux is equal to, we will get as BA. Area is constant for the loop. Field is constant. That's why the flux is also constant. They gave in that the field is constant. They gave, right? And area of the loop, it's a square loop. The area is also constant. That's why the flux is constant. When the flux is constant, induced EMF is 0. Induced EMF 0 means current is also 0, right? And next, the option, right option is the fourth option. Let's go for the next one. That is 22 question. What is this? Magnetic flux they give, induced EMF they are asking. Induced EMF formula is the negative rate of change of magnetic flux. Here we write is minus d by dt of phi we have to write, where phi is the 5t square plus 3t plus 16 we have to write. And here differentiation we have to do minus 5 we have to write aside, t square d by dt is 2t. Okay, plus 3 into d by dt of t differentiation with respect to t is 1 plus 16 alone constant differentiation is 0, and finally we are getting that is minus of 10t plus 3 I am getting. But they are asking the induced EMF at a time t equal to 4 seconds, right? Induced EMF is how much? Then you should substitute the 10 time as 4, then we will get like this. Then finally we are getting minus 43. Is it correct? Minus 43 volt. The second option is the right option. Let's go for the 23 question. The 23 is that which of the following graphs represents the variation of current with frequency in AC circuit containing pure capacitor? For the pure capacitor, current formula is V naught by I equal to I naught into I naught into I equal to I naught into sine omega t plus pi by 2 we will get. Plus pi by 2 we will get. Okay, where I naught formula, if you will write I is equal, we will get as I is equal, we will get as v naught by xc, but xc formula is 1 by c omega, we will write 1 by c omega. C omega will goes to the numerator. We will get v naught into c omega, we will get sin omega t plus pi by 2 we will get. And here current proportional to omega and current proportional to frequency will get, because omega is equal to 2 pi f. We will get the third option, right? And the next, let us go for the next question, that is question number 24. AC voltage 20 volts. 20 volts AC voltage. For example, this is AC source voltage, but they gave 20 volts. AC source voltage they gave means that is RMS voltage. RMS voltage is the 20 volts. That is applied to a circuit consisting one resistance and along with one coil. This coil have the inductance L. Okay, it does not have any resistance, they are connected like this. Then our question is that if the voltage across resistance is VR, then what is the voltage across the coil, right? There is a formula is there in this, right? That is, if the LCR circuit is there, in LCR circuit we know, right, the net voltage V is equal to, we write as total voltage, if we write as we write as total voltage is equal to VR square plus VL minus VC whole square. This is the formula when inductor, capacitor, resistor, if three are connected to AC source and total voltage is V and the voltage across inductance is VL and voltage across capacitance is VC and voltage across resistance is VR. This is the relation that we discussed previously. Now here there are only two are there. That's why here we write as V is equal to under root of VR square plus VL square only we have to write. It's not DC. In DC directly we will add V equal VR plus VL we write. But in AC we should not use like that. Okay, VC is 0 at here. We substitute all values at here. V is the total voltage. Total voltage is the 20 under root of voltage across resistance 12 square, voltage across inductance we should find out. Then we will get as 400 is equal to 12 square means 144 plus VL, and VL is equal to, we will get as 250 VL square equal to 256, and finally VL is equal to, we will get as root 256 means 16 we will get. Answer is the 16 volts. 24th right answer is the first option. Okay, right. Let us go for the next question. That is the question is the this one. You see, this is in LCR circuit it will possible, and in CR circuit also it will be possible. The fourth option is the right option. Next one is the 26th question. 26th question. You read the question properly. Okay, this is the section B. What happening it here? A cylinder of radius smaller and length L placed in uniform electric field parallel to the axis of the cylinder. Total flux through the cylinder is what? For example, this is a cylinder. This is a cylinder, and this cylinder is kept in the electric field. This cylinder is kept in the electric field, right? Uniform electric field. The electric field, a cylinder of radius smaller. The radius of the cylinder is R, and the length of the cylinder is L. Now what we are doing, this cylinder is kept in the uniform electric field. Then total flux is how much? Net flux. We know that net flux is that entering flux plus leaving flux. Okay, entering flux is what it here? Net flux they are asking. Entering flux we want. Entering flux, if you want, flux formula is EA cos theta. You see, electric field is right side at here, but area vector left side. Then here angle is 180. When angle is 180, we write as minus EA. And leaving flux we can write. Leaving flux. Leaving flux is also Ea cos theta. Here we write electric field is right side while leaving, and area vector for this also right side. Then both are along same direction. Ea we write. Then entering flux negative, leaving flux positive. Then net flux is, we have to add entering plus leaving. Entering plus leaving. If you will add both of them, what you will get? Entering flux plus leaving flux. That is, entering flux we will take negative, and the leaving flux we will take positive, and the total flux is zero. Right? The net flux is zero because there is no charge enclosed in the cylinder. Right? And let us go for the next question. That is, two parallel thin metal sheets have equal surface charge densities. Sigma is equal to 26.4 into 10 to the power of minus 12 coulomb per meter square. There are two parallel metal plates, thin metal plates, and they have opposite surface charge densities. One is plus and other is minus. We want to find out the electric field at the middle. Then how to find out the electric field at the middle? In order to find out the electric field at the middle, we have a formula, that is electric field due to first sheet it will be there, that is E1 away from the positive, due to negative sheet also there, that is E2, that is also away towards negative. Electric field is away from positive and towards negative. This is the first sheet, this is the second sheet. Due to first sheet away from positive, that's why right side. Due to second sheet towards negative sheet, that's why we write as E1 plus E2. And E1 is the formula due to electric field due to one sheet. We know formula very well, sigma by 2 epsilon naught plus sigma by 2 epsilon naught. If you will simplify it, we will get the sigma by epsilon naught. Sigma is the 26.4 into 10 to the power of minus 12, and epsilon naught value you know 8.85 into 10 to the power of minus 12. If you simplify this, we will get the 3 volt per meter or Newton per coulomb. The answer is the fourth option. Okay, and the next let us go for the 28. What is the 28? The 28 answer is the fourth option. Okay, next let us go for the 29. The 29 is that three charges 2q minus q minus q are placed at the vertices of triangle. Then the electric field and potential at the center they are asking. You see here, this is the triangle. Okay, triangle. There are charges 2q is kept at one place, minus q is placed kept at the other place, other corner, minus q. They are asking the electric field at the center. Electric field at the center. Okay, and electric field due to minus q charge will be there, that is towards the minus q, and electric field due to this minus q also there, that is towards the minus q, and due to plus 2q also electric field is there at here, that is away from plus 2q. If you find out the net of E1 and E2 and E3, okay, net of E1 and E1, E2, E3 never be zero because they are not in opposite direction, right? Then that's where E net electric field is not equal to zero. But if you add the potentials directly we will add. No direction, it's a scalar. We will add directly. Okay, that is, this distance is r, and this distance is r, and this distance is r. If you will add potentials due to 1 by 4 pi epsilon naught into 2q by r due to 2q charge, and due to minus q charge we write as 1 by 4 pi epsilon naught into minus q by r plus 1 by 4 pi epsilon naught into minus q by r. If you will add them 0, we will get E is not 0 and V is equal to 0. That means the third option is the right option. Okay, now let us go for the next question. You read the 30th question yourself. Two parallel plate capacitors X and Y have the same area. Two parallel plate capacitors X and Y have the same area of each plates. This is the parallel plate. it is X, and another parallel plate is the Y. Two parallel plates, except they have the same area. Each one area is A. They have same separation. Separation is D. Separation is D. Means area is constant. Separation is constant. And X has a area. X has A rise dielectric, and Y has a dielectric constant 2. Okay, X is the air dielectric, means air value is 1. Then question is that between its plates, and they are connected to in series to a battery 12 volts, then ratio of electrostatic energy stored in them. Look at here, there is a X capacitor and the next Y capacitor. They are connected in series to a battery of 12 volts. The battery voltage is 12 volts. Then our question is that ratio of energy stored in the two capacitors. Energy stored in the two capacitors. Right? In series, what is constant? In series, charge or current is constant. Charge constant, current constant. Then energy stored formula is we write as Q square by 2C. We write as U inversely proportional to C. We write as U1 by U2 is equal to C2 by C1. What is C2? C2 is the capacitance of Y capacitor. It is the Kc we write. Its formula is K epsilon naught A by D. Okay? K epsilon naught A by D. And C1 is the capacitance of the X capacitor, first capacitor. Its capacitance, it is in X capacitor, air is the medium. Air is the medium. If air is there, then its formula is only epsilon naught A by D. We will get the K by 1, that is the 2 by 1. The third option is the right option. Next 31. 31 is what? The 31 answer is fourth option. Fourth option is the correct option. And 32, second option. 33, fourth option. 34, fourth option. Now let us see the 35. What is this? There are three resistors are connected in series. You see, this is R1, and the next one is the R2, and the next one is the R3. These are the three resistors are connected in series, right? They are connected to a battery. This is a battery whose potential is V. Okay, right? This is considered as one plug key. And now what happening? What we want? Okay. Now R1, here in series the current is constant, right? Current passing through the R1 they give. Current passing through the R1 is 2 amperes, means current passing through any resistor is 2 amperes. Current is constant. Okay. And R2 value they give. R2 has a resistance 3 ohm. And R3 across dissipated power they give. Right. P3 we can take. Okay. And R2 resistance they give. And power dissipated across the third resistance R3. Heat developed across the R3 resistance per second they give 6 watt. Then question is that what is the voltage across the third resistance? We have to find out the voltage across the third resistance. Yes, it was very simple to find out the voltage. Power across the third resistance, we know formula, that is the voltage across the third resistance into current. Power is what? 6. Voltage across the third resistance is we have to find out. Current is 2. Then voltage across the third resistance is 2 3 ja. Then 3 volts is the answer. Very simple solution. Okay. And let us go for the 36. What is this 36? Listen very carefully. What happening in this? this is a graph between the voltage and current for a cell. Okay, right, whose internal resistance is the internal resistance of the cell should be a straight line plot showing the terminal potential difference of a cell as a function of current. Okay, this is a battery. This is a battery. Okay, across that terminal voltage is V they gave, and the current is I they gave. Okay, current is I. Now the question is that right, internal resistance we have to find out from the graph. They give the um, we know terminal voltage when during the discharge or the charge, right? Terminal voltage formula is E minus IR. V is equal to E minus IR. You see here current on x-axis. When current is 0, if current is 0, the terminal voltage equal to EMF. That means here when the current is 0, you take here the voltage is 5.6 maximum voltage. This will become the EMF. Okay, the voltage is the 5.6 volts. That will become the EMF because when current is 0, EMF is maximum 5.6. Okay, and the next one is the here the potential difference is 0, terminal voltage is 0. If okay, at a 2 ampere current, at a 2 ampere current, at 2 ampere current, terminal voltage is 0. Is it correct? Voltage is decreasing, decreasing, decreasing. Maximum voltage is called as EMF, and voltage is decreasing, 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 decreasing. At 2 ampere, voltage becomes 0. At voltage become 0 means current become maximum. Current become maximum at here. At this location, what happens? Terminal voltage formula is E minus IR, right? If the current is 2 amperes, if the current is 2 amperes, V is 0. V 0 we write. E value 5.6 we know. Current value we know 2 amperes, and R, and 5.6 is equal to 2R, and R is equal to, we will get as 5.6 by 2. 2 2 ja 4, 2 8 ja, then 2.8 ohms we will get. The right answer is the first option. Let us go for the next question. The next question is that 37. The 37 is that the length of the potentiometer wire. I think we will discuss in the part 2. Okay, and I am closing. If you want, you can try for this solution. You will get the potential gradient formula is IR by L. This formula we will use. I is equal to, we have the formula E naught by R plus RS plus R into R by L we have to use, and EMF they are asking to find out. EMF formula is phi L, where small l is the balancing length. These two formulas you should use to solve this problem. Okay, and the remaining we will discuss later.